Welcome to the course. Next topic, photochemistry of aromatic hydrocarbons. Benzene in presence of, if you do sulfuric acid, sulfonation occurs. Nitration occurs. It means in the presence of heat, substitution occurs. Okay, in presence of a light, it undergoes isomerization. Okay, in the presence of light, the benzene undergoes isomerization to give the different products. Okay, under thermal condition, aromatic hydrocarbons retains atomic property, but under photochemical products with the loss of aromaticity. Therefore, aromatic hydrocarbons thermally stable, photochemically highly labile. Okay, thermally, if you do thermal reaction, okay, what happened? There won't be any change in the aromatic ring. Substitution occurs. In place of hydrogen will be substituted with other groups. But if you do under photochemical conditions, what happened? The aromaticity will be disturbed in the reaction. That's why aromatic hydrocarbons are thermally stable and photochemically highly labile. Okay, they will undergo isomerization. First, what are the different types of reactions these aromatic compounds undergoes in presence of a light? Okay, types of reactions: ring isomerizations, ring rearrangements, photocycloadditions, electrophilic nucleophilic substitutions. These are the types of reactions occurs by the aromatic compounds. Okay, different isomerization reactions and all those things. Okay, if you heat, they will undergo substitution. In the presence of light, they will undergo first excited state, high energy, then in presence of light, non-aromatic compounds, highly strained molecules are formed as a product. Okay, if you do heating, substituted aromatic compounds will get. If you do in presence of a light, they will form non-aromatic compounds having highly strained molecules will get. Okay, benzene in presence of light, it forms pi to pi star transition state. Okay, benzene absorbs three types of wavelengths. Absorption occurs at three types of wavelengths: lambda value 254, 204, 180 nanometers. 254 pi to pi star, ground state to singlet, first excited state, 204 to second excited state, 180 to third excited state. This is the thing. Okay, for S0 to S3, S0 to S2, S0 to S1. This is from S1 to T1 triplet, first triplet transition state. Okay, here it is undergoing ISC, means intersystem crossing, singlet to triplet state it is crossing. Okay, 250 nanometers, 204 nanometers, 180 nanometers. These are the different regions where the benzene shows the absorption. Okay, you have to expose the benzene molecules to any of these. Okay, it will undergoes isomerization. The light wave having 254 nanometers, light wave having 204 and 180, like that. Okay, here benzene in presence of H nu and 250 nanometers in singlet ground state to first singlet excited state. Okay, pi to pi star transition, singlet transition state. It is forming fulvene and benzovalene as a products at 250 nanometers. Okay, at 204 nanometers, okay, same, along with that fulvene and benzovalene, along with that another one, dibarbenzene also it is forming, third one at 204. Okay, then pi to pi star triplet transition state, it is forming dibarbenzene. Okay, it won't form other products, only dibarbenzene is formed if triplet. Okay, triplet transition state is involved, then it forms a dibarbenzene. Okay, you have to remember at which nanometer what are the products. Okay, here benzene in presence of H nu, first what happened? The homolysis of this bond will get 4 radicals, 1, 2, 3, 4. Okay, then this radical will form a pi bond, then you will get this. Here one radical will be left, here one radical will be left. Okay, homolysis of this will get one radical here, one radical here. Homolysis of this, one radical here, one radical here, pi bond homolysis. Okay, then this radical will form a pi bond here, and here will be the radicals left over. Okay, then again homolysis of this bond will get radical here and here. This will be forming pi bond. Now here you are getting the radical, just rearrangement of these radicals. Okay, then you are getting these radicals here. Okay, then what happened here? This is undergoing homolysis. Okay, if this bond is homolysis, then what happened? This bond and this bond homolysis occur, you will get double bond here and here. Here you will get the radicals. If homolysis of this occurs and homolysis of this, will get double bond here, here two radicals. This is the one. Again, if this undergoes homolysis, if this is undergoing homolysis, you will get one radical here, one radical here. Now this radical and this radical will combine. It forms a bicyclic compound. Okay, if this homolysis occurs, this radical and this radical will form a bond. Okay, here you will get a bond, and one radical here, one radical here. You will get bicyclo 3, 2, 0 hexenyl biradical you will get. Okay, this is the one thing. Okay, rearrangement of the benzene. Okay, rearrangement of benzene. How we were getting the fulvene and benzovalene products and divorce benzene. Okay, first that whatever the 1,4 biradical is formed, that we are taking 1,4 biradical, 1, 2 hydrogen shift. Okay, here this undergoes homolysis. Already here radical is there. Okay, if this is undergoing homolysis, we will get hydrogen radical. Okay, that hydrogen radical is taken by this. This how it is found means here whatever the rearrangement, we are getting the bicyclo 3, 2, 0 hexenyl biradical. That biradical at 1, 2 hydrogen shift. From here hydrogen will be shifted to here. How? By the breakage of this CH homolysis. Okay, here we will get H radical, and this carbon will get one more radical. Okay, this hydrogen radical combines with this radical, then here one hydrogen is added. Before one hydrogen, one is shifted from first position. Now here you are getting a radical. It is already a 1,4 biradical. Here already radicals are there. Okay, then here now homolysis of this bond occurs. Homolysis of this. Now if homolysis occurs, what happens? Here you will get a radical, and here you will get a radical. This radical will form a double bond here. Here, see, double bond. Then if this is undergoing homolysis, here you will get a radical. That radical, this radical will form a double bond. Okay, we will get a fulvene. That only fulvene. How we were getting fulvene means, first you will write the how the 1,4 biradical is forming. Then from the 1,4 biradical, after 1, shift, you are getting the fulvene. Okay, simple. 1, 4 biradical. Okay, here at 1, 2 shift. Okay, 1, shift followed by this 3-membered ring is very strained always. That will be readily to cleave. Okay, here by the breakage of this bond, you will get radical here, double bond. Here radical, here double bond. Okay, like that fulvene is forming. Then benzovalene, 1,4 biradical only. Okay, 1,4 biradical. By combining this two, this you are getting benzovalene. That only we are writing like this. If you are twisting, this is coming up. That's it. This 5-membered ring. Okay, benzovalene. How the benzovalene is formed. Then how the divar benzene is forming. The divar benzene is forming in aromatic ring. First step, how it is formed in the first radical. This you are taking. Okay, then from that. Okay, then from that, by the cleavage of this bond, again you will get here two radicals. This one. Okay, this only we are representing like this. Okay, here by representing like this here. Then this and this will combine to form a double bond here. Then that only we are representing like this. Okay, here this and this will form a bond here. So by cleavage of this, here you will get the radicals. Here already radicals are there, they will combine. So this is how the Dewar benzene is forming. Okay, then isomerization of alkyl benzenes. How the isomerization occurs? Okay, alkyl benzene. This is about the benzene. Okay, alkyl benzenes. Okay, means substituted dimethyl. Dimethyl, this is ortho, it will convert it to meta and para isomerization. Ortho dimethyl benzene converted to meta, meta will convert it to para and after isomerization. At lambda 250 nanometers, ortho is converting into meta. Okay, this is how they are converting. Okay, then if you take mescaline tri-substituted, it is forming benzoylene intermediate 1, 2, 5 trimethyl benzene influence of HNO. So this is isomerization of the photoisomerization. Whatever the benzenes we are getting benzoylene and they will get substituted benzoylenes here. Because benzene is substituted, benzoylene also will get the substituted products. Okay. This is about the photoisomerization of the benzene. Okay. We can write that. Okay. Benzene influence of HNO 250 nanometer, benzoylene and fulvene 160 to 180 we were getting along with the Dewar's benzene. These are the mechanism how we were getting fulvene, how we were getting this, how we were getting this Dewar's benzene. Okay, Dewar's benzene. This is photoisomerizations. So this is about the photoisomerization and the excited states of the aromatic compound. Thank you.